Okay, so we are back. We'll start with this shoe shuffling. So the question mentions a class of students got bored wearing same pair of shoes every day. So they decided to shuffle their shoes among themselves. In this problem, a pair of shoes is inseparable, considered as single object. Shuffle their shoes. In this problem, pair of shoes is inseparable, considered as single object. There are n students in the class. You are given array S in non-decreasing order. Okay, ascending order. Whereas size the shoe size of the ith student. The shuffling of shoes is valid only if no student gets their own shoes. If every student gets shoes of size greater than or equal to their size. The shuffling of shoes is valid only if no student gets their own shoes and if every student gets shoes of size greater than or equal to their size. You have to output a permutation P denoting valid shuffling of shoes where ith student gets the shoes of the pith student. Pi not equals to I and output equal to -1 if a valid shuffling does not exist. So it looks like a type of greedy problem. These are the description of constraints given in the question. N and then we have n integers, the show sizes and do not exceed n power 5. Output for each test case, print the answer in single line using following format. Okay. Valid shuffling does not exist, print -1 is the answer. If valid shuffling exists, print n space integers and permutation of 1 to n denoting valid shuffling of shows, where the ith student gets shoes of the pth students. If there are multiple answers, print any of them. Okay. So now we have the mm, yeah, 1 1 1 1 1 1, and he just use 5 4 3 to 1. Any permutation will represent valid shuffling since all students have equal shoe size, thus anyone can wear anyone's shoes. No valid shuffling is possible here. 3 6 8 13 15 21. Why is it not possible? Student get the shoes of PH student. Okay, and also every student gets size of shoes of size greater than or equal to their size. Shuffling if was valid if and only if no student gets their own shoes, and if every student gets shoes of size greater than or equal to their size. Okay, shuffling is this is the main thing. No student should get their own shoes, and moreover, every student should get shoes of size greater than or equal to their size. Hmm. So here the shuffling does not exist because we have 3, 6, 8, 13, 15, and 21. It's not possible. If I give 6 to this person and 3 goes here, then this person won't be satisfied because he did not get a shoe of greater than or equal to the size. In the second test case, no shuffling is possible. In the first test case, we can shuffle. Anyone can wear anyone's shoes. Three, 6, 8, 13, 15, and 21. 3, 6, 8, 13, 15. Okay. The constraints are between 1 to 10 power 9 and the shoe sizes are increasing. Let's try some custom test cases over here. This is one example. Let's say we have 3, 3, 4, 4. Is it possible to shuffle? Yes, it is possible to shuffle because he can exchange this thing. He can exchange with this person. So that it's possible to quite possible to shuffle them. But what if we have 3, 4, 5, and 5? If I shuffle them both, 5 and 5 can be shuffled easily. I'll be getting here 5. But these both cannot be shuffled. So maybe there's something to be done here. This person can take these shoes, but he won't be satisfied because he's not getting shoes of size greater than 4. Mm, Moreover, if I do it for 3, if I exchange shoes of 3 and 4, he'll take the shoes of 4 size and he'll take shoes of 3 size. No, this also doesn't work because the minimum value needs to be adjusted here. There should be someone who is ready to take the minimum size of this shoe, and this will only happen when there is someone less than 3 or greater than 3. Let's say we have like 3, 2, 4, 5, 5. Now 3 and 2, 2 is ready to take this shoe. Then we can assign index 1 to it. And 3 will take this thing. But what will 2 take? Again, we need 1. The number 1 which will take the pair of size 2. And also there should exist another duplicate 1 which should be ready to do that. It's somewhat complicated actually. 3, 3, 3, 4, 4, 4. This can be done easily. I think the main recipe is to have frequency of all the elements. Each element should have frequency greater than 0. Greater than 1 actually. This is the main thing of each Si for I equals to 1 to n. Now, and then only it can be tackled easily. Otherwise, there's no other option. If I go with 3, 2, 1, 4, 5, 6, then 1 can take this shoe, and 2 will take this shoe, 3 will take this shoe, 4 will take this thing, and 5 will take this shoe. But what will be in the place of 6? If I take another 6, then another 6 will take this shoe. But what about this 6? So, according to me, there should be frequency of greater than equal to n. Of each element, the frequency should be greater than 1. That's the thing. Let's say we have 3, 3, wait, sorry, 3, 3, 2, 2, 1, 1. They both will exchange their shoes. They both can exchange their shoes. And these both can exchange their shoes. Moreover, it's in, okay, okay, okay. The array is in descending order. I mean ascending order. 1, 1, 2, 2, 3, 3. Then if suppose it was 1, 2, 3, 4, 5, 6, then also it would not be possible. Or let's say it was 1, 1, 2, 3. Let's leave this and just consider this thing. These both can exchange their shoes and these both cannot exchange their shoes. Yeah, that is the thing. The frequency of each element will be greater than 1. If it's not, then we'll just output a 1, minus 1. So the first thing will be, first thing is, if frequency of Si is less than 1, is equal to 1, then I just have to simply print minus 1. Or else, what can we do? Let's say I have taken this example 1, 1, 2, 3, 3. And as indices are 1, 2, 3, 4, 5, 6. What I'll do is I'll be storing, since SI is between 10 power 9, I think we can create an array of 10 power 9 order, or else it's in ascending order, so I don't need to worry about it. I'll just create a map and I'll assign number here and frequency to it, and same here. Now what will I do is I'll just print these indices in reverse. If it's 2, then I'll print 2 comma 1. Then I'll increment another 2. Then if it's 2, the incremented 2 I'll print here 4, and then 3. Then another 2 I'll increment to this thing. Another 2 into 2 I'll increment. Hmm. Yeah, I guess that will work. Let's just move to the coding part. Visual Studio Code. Minute. I have to parse. Yeah, n. Then my array will. I'll be just printing minus 1 if it's not possible for me to print that thing. Or else, I think I can use another for loop here within this, where I'll be iterating all the frequencies. What is the time complexity for iterating through a map? Mm, If you just look at the worst case, then the map might have 10 power 5 elements, each of frequency 2, Sum of n does not exceed 10 power 5, that's fine, but let's assume it. Worst case, if h has frequency 2 into 10 power 5, then I'm just iterating here 2 with 2. Ultimately, this product will add to n. If suppose I have 3 values of 1, or let's say I have 5 ones here. So there will be only one element in the map, and I will be iterating to the 5 times here. 5 into 1, that will be 5. Yeah, we'll try once. There's no problem in trying. I greater than equal to increment value. I minus minus. Well, I think int n, then sn, taking the import. On my test case, it didn't work. Wow, it's a really extraordinary answer. I'm doing a mistake somewhere here. That's the thing. If this gets corrected, then I'm good to go. I'll just set increment to 0 and I greater than increment. Now let's try. 1, 6, 1, 1, 2, 2, 3, 3. Okay, 2, 1, 4, 3, 6, 5. Very good. Now I'll just submit and look. Will it pass or not? Oh no. Okay. Test case 1. Student 3 received the same shoe. Oh. Okay, okay, okay. You can just apply some other method for shuffling. All you need to do is just shuffle them. 5, 4, 3, 2, 1. Since 3 is in between, that is why he got the same shoe. I cannot even go for hashing here because my array size is too large. It's, it is somewhat 10 power 5, I guess. It's 10 power 5, but SI takes value till 10 power 9. Then I have to create array of 10 power 9 elements. All I need is to tackle this problem. 5, 4, 3, 2, 1. 5, 1, 2, 3, 4. Then I have to create some cases where if the frequency is odd and if the frequency is even. If it dot second modulo 2 equals to not equals to 0. If the frequency is odd frequency, then what I'll do is, first of all I'll print the frequency, then I'll decrement it by 1, then I'll just print 1, 2, 3, 4, just like how he did. I'll, or else in the else condition I'll apply this. But the increment will for sure happen here as well, or else I won't be able to follow up with the indices. Now let's try with this. This test case got passed, that's a great thing. But I have to run with some of my own test cases. 1 6 1 1 2 2 3 3. Okay, this also works fine. Now let's try with another test case. 1 6 1 1 1 2 2 2 3 1 2. That's the thing which I knew it. This mistake will happen. 3 1 2, but here it didn't increment. The increment didn't take place. What happened is it dot second 3 modulo 2 not equal to 0. So increment plus or equal to it dot second. Increment became 3 and C out it dot second, which is the that frequency element, and minus minus. Then for int I equals to it dot second plus increment. Now we'll print the it dot second, then minus minus. Then for int I equals to not 1, but I think we can update it later as well, the increment thing. Now here I'll just print it second is equal to 1 1 1 1, no, not 1. It will be the increment thing. The increment is 0 here, but increment plus 1. Now let's try it. 1 6 triple 1 triple 2. Okay, 1 2 3 3 got repeated again. Hmm. 5. It should be like 5, not even 5. It should be 6 here. 6 should come here. 3, oh, this is 3. 4, 5, 6. 6 should come here. 6, rather than 6, 5, 4, we'll get 6, 4, 5. Like 3, 1, 2, we'll get 6, 4, 5 here. Hmm. How to get a 6, 6, 6? I should use the property of descending order here actually. 10 power 5. Even if I know the indices, that's enough to know the frequency. What do I mean by that is, suppose I know the index of 1. It is 0, 1, 2, 3, 4 and 5. It will be sufficient that if I know these indices 5, 3 and 1, because if I know these indices till 0, I'll print it and then I'll increment by minus 1. One, 3, 5. Let's say I have triple 1. 0, 1, 2. I got the indices. 2 minus 0 plus 1 is the thing. 3, and that is 3 elements. Now what I'll do for 0 to 2, or let's say 2 to 0, I'll just print 80 dot second plus or equal to increment. I have to analyze this test case here. Increment equals to 0, 3 modulo 2 not equal to 0, 3 plus or equal to 0, C out 3, 3 minus minus, I is equal to 1, 2, I is equal to 2. I'll just print 1 and 2. Then increment, in the increment I'll add 80 dot second, which will be 2. Okay, now 80 dot second plus equal to so 3 plus or equal to 2. No, 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 no. I have to add plus 1 here. That is what I wanted. 6, 4, 5. No. 6 plus 2 is 8. 1, 8, 1, 1, 1, 1, 2, 2, 2, 6, 6. Where did 11 and 10 come from? This is 8, 7 and 8. My increment value will be 6 here. I is equal to 80 dot second 2. 2 plus 6 is 8. 8 and I greater than 6. I minus minus. C out I. So I'll be printing 7. No, no, I'll be printing 8 and then I'll print a 7. That's it. And then why am I getting 11 and 10? All I need is to debug this code and I'm good to go after that. See out increment. Let's just look the value of increment. after every iteration. The same test case. 1 8 1 1 1 2 2 2 4 4. Increment equals to 3. Okay. Increment equals to 9. Increment is 3, that's fine. Increment is 9. How can it be 9 here? It should be 6, not 9. IT dot second is 2. I'm iterating throughout the map. If the frequency is not divisible by 2, okay, IT dot second. I'll just print 3, then I'll print 1 and 2 as equal to increment plus 1. Increment was initially 0, so then I printed 1 to 2. Okay, then increment I have set it to 3. Then again frequency not divisible by 2. IT dot second is 3. It's not 3, it is the frequency. 3 plus 3 becomes 6. So we have outputted as 6. Then minus minus, it will be 5. 5 then I equals to increment plus 1. Increment is now 3. So 3 plus 1 is 4. 4 I less than or equal to IT dot second. I equals to 4 and I less than equal to IT dot second. What is IT dot second now? It is 6. I less than equal to 6. It will be 5, sorry. Then increment plus or equal to 3 plus or equal to IT dot second plus 1. IT dot second plus 1 is, it will be 9 plus 2. No, 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 I mean it will be 3 plus IT dot second is 3 plus 1. It should be 10. 1, 1, 2, 2, 6, 4, 5. Then increment will be 9 because it will be 3 plus 6. It will be 9. Or else I'll start with value of 1. Increment equals to 1. Then auto IT equals to m if IT dot second. Modulo 2 not equal to 0. Then I don't need to do plus equal to increment. Minus 1. Second, I is equal to increment plus 1. Increment will be 1. 1 plus 1 is 2. 1, 8, 1, 1, 1, 2, 2, 2, 4, 4. 9, 8. I'll see the editorial. I'll just take small hints from here. What happens to other people when a person receives a shoe greater than his size? What happens when a person has a unique shoe size? If, shuffling will not happen. This code is too long to read. Let's just see this thing. Observe the number of shoes pair greater than size is limited for any student. So if student J wears shoes that are greater than their size, then some student I who has greater size greater than student J will compromise this size. Exist when student gets shoes of size greater than on, then get shoes of student I where SI, then for all pairs of shoes SJ, one pair will go to student whose size is smaller than this chain will continue, and so no greater than that. Then there will be existing pair of shoes that student okay, thus evaluate shuffling. Every student must get shoes of same size as their own. If more than one student has same size shoes for all the shoe sizes, yes, that's correct. A valid shuffling can be generated shoes with the same shoe so that no one get their shoes. This can be done, for example, in cyclic rotation. Okay. A valid shuffling can be generated by rearranging shoes with the same shoe size. Okay. That's the logic which I have applied. All I'm where the place where I'm stuck is with the cyclic rotation thing. I define the rotator. There is some inbuilt function to rotate. Okay. We'll also just try with rotation here. Oh, this is the first time I'm seeing some inbuilt function called as rotate. Then I can do this. No need to read this then. Rotating vector to places right such that element becomes first element. Hmm. Then I will not be needing this. How will I rotate this? I will create a vector, vector int v. Now what I'll do is I'll just push the frequencies. I mean the high element of the highest frequency here. I'll just explain it. As I not equal to as I minus 1, and v dot pushback I. Now let's just print the vector and see. 3 and 6. 1 0 1 2 3 I minus 1, let's say. 0 1 2 3 4 5 6. Okay. Hmm. 4, yeah. 0 1 2 3 4. Now what I'll do is I'll rotate it. S plus 0, not S plus 0. Where do I need to rotate from? S comma S plus IT. 0 1 2 3 4 5 6 7. 0 1 2. 2 will be stored here, then 5 will be stored here, and 7 will be stored here. 0 1 2 1 1 1 triple 2 4 double 4. So 0 2 will be stored here, 3 4 5 will be stored here, 7 will be stored here. Now what will I do is I'll just assign min equals to 0. I mean I'll create a variable called last index. Last index is equal to the IT. Then initially I'll initialize it 0. Then what I'll do is v dot rotate 0 comma. I'm not worried about rotating it however I want. I just need to. But if I rotate this thing 1, 2, 3, 4, 5, it will become 5, 4, 3, 2, 1. There's no point in rotating like that. Right rotation, right rotation. We'll try with this rotation only. Instead of 2, I'll write the average index of that thing. Very good. Finally, nothing that great. I just stored the indices of this first three thing and the last thing. Then if the frequency is odd, then I first printed the three, then I printed one, two to avoid the overlapping. Similarly here, and if the frequency is even just I printed the numbers in reverse order. Now I am going to submit this. It took me really around 1 hour to solve this. I think mouse stopped working. Oh, finally, it got accepted after 1 hour. After 1 hour, I was able to solve this. And this next question after that, I'll be just halfway toward these 1,000 difficulty problems. Then more half to go. Took some time, but maybe by solving, I may get comfortable day by day. Then we have to move to this 1100 and 1200. Still, I'm a newbie in this. I have to rank up, so yeah. Now, black and white stripe. We have a stripe of checkered paper of length, and each cell is either white or black. What are the minimum number of cells that must be recolored from white to black in order to have a segment K consecutive black cells in the stripe? If the input data is such that a segment of K consecutive black cells already exists, then print 0. First line number of test cases. What is he saying? You have a stripe of checkered paper. Each cell is either white or black like this. What is the minimum number of cells that must be recolored from white to black in order to have a segment of K consecutive black cells on the stripe? So we need minimum. If the input data is such that segment of K consecutive black cell already exists, then print 0. This is the number of test cases T and N and K. The second line consists of letter white and black. Line length is N. Does not exceed 2 into 10 power 5. For each of T test cases, print an integer minimum number of cells that need to be reprinted. Okay. K equals to 3, so we need at least 3 consecutive. This is 1. This is 2. And this is 0. And this is 1. Okay. It's a easy question. Yeah. Int N, then int K. Sorry, it's a string. Now, what I'm doing is I'll just enter through the string. This is the count maintain. I'll maintain the count. If it is black, then I'll do C++. If else, if it's not black, Then firstly, if the count exceeded the value of k or is equal to the value of k, no, I'll just print it in the last. I don't have to do C++ here. And first thing is to maintain the C and another is answer. Now, if the color is black, then I'll do C++. Else answer plus plus. If C greater than or equal to K at any point, then I'll just well, that's it. That's what we had to do now. Failed. int t, c int t, int n, int k, string s, scene s, okay, and then 0 answer equal to 0. Hmm. Oh, missed the last iteration. It was a D question in some Division 3 contest. It was quite easy. The thing is that in this contest you have to go till end and check. Oh, it failed on which test case? Second number deferred. Expected 0, font 3. What is the second test case? 0, 1, 2. Okay. I have to increment the answer. Moreover, I have to increment C as well. Now it will be good to submit. That's the confusing thing here. I didn't increment C as well. If I increment C, that means I'm changing the color from white to black. Oh no. No. Again, second number deferred. Output is 1 and the expected is 0. Okay. First we'll check the existing segments, then we'll go on for doing this thing. triple W double B. And then I have to check for existing longest subsegment. Suppose if I don't have that, then, then let's say my segment is something like www bbw, and I need around three consecutive B's. What will it do is, if SI is B, it will increment this L's answer plus plus C plus plus. I mean C plus plus in the sense it will increment the count here. White, white, black, black, white. Answer will come as 3. So the answer was 1 year. This is the maximum streak of B. Cross check all the test cases actually. Suppose it is WW triple W B B. Let's say here it's B W B W. Now let's say I have want to achieve a streak of three consecutive blacks. Then what will I do is 2 minus 1. Suppose I want a streak of 4 consecutive blacks. Then my answer will be just 1. One will be my answer because I'll just change the W where my cursor is there. I'll change this W and then I'll be good to go with the answer. But the thing is, how will I arrive till that conclusion? Or else, as the previous question, like how I did in the previous question, I'll store all the indices of blacks and I'll check with that. 0, 1, 3. 0, 1, 3. BBW. To obtain segment of K cells of black color, we need to paint all the white cells of the segment black. Okay, and then go through all the segment of K. Segment black, then go through all segments of length K. There are only n minus K. There are how many n minus K? Okay, there will be n minus K segments of length K, and choose a such segment among them that the number of white cells on it is minimal. You can quickly find out number of white cells in the segment by prefix sums. Okay, that was the thing here. I don't think we even need the prefix sum concept here. What I'll do is just, if it's a white color, then I'll store the uh, I mean, if it's a white color, then what I'll do is I'll just store the value of it. If s equals to b, store the index of that number. A prefix sum, how can it be done? We have to take the sum of prefixes. W, B, B, W, 1. You have to find the number of W's in that particular segment. S equals to W. Hmm. No. What I need is to find minimal number of W's. There will be n minus k iterations. This will go on as usual, but I'll just create another for loop. N minus k, 5 minus 3, 2, 0, 0, then I plus 2 is 2, 1, 0, 1, 2. is equal to n minus k, let's say. Minimum of min w and wi. And what I'll do is just print them. Secton error and k string s wn equal to 0, min w equals to n plus 2, I is equal to n minus k, I less than n, I plus r equal to n minus k. Okay, minimum of this thing, comma wi. It only failed on this test case. On remaining test cases, I got quite good answer. I mean, W equals to W of n minus k 5 minus 3 is 2. I'm having problem with the iterations here. N minus k plus I minus wi minus 1. My I will initially start with n minus k. Okay. N minus k comma n minus k plus 1. I'll just see how did he do this rather than being stuck here. He stored all the things. Oh, okay. That's what I did anyhow. I'll also get the prefix sum as the same thing. Even if you want, I can just print. Result is equal to wi minus wk. Okay. He created n plus 1 elements. That's why I did this. Okay. I can do it. I'll also do the same thing. N plus 1. For int I equals to k, I less than n. Okay, equal to n, let's say I plus plus. Hmm, okay, now I k less than equal to n. What will I do is k, k is 3 here, minus 0, or 5 minus 3. Wait. Hmm. Wk minus wk. No, 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 no. wi minus k. How is that so? W3 is this thing, and W3 minus 3 is 0, this thing. Okay, well, I understood. Now, if it goes on incrementing, it will become 4. 4 minus 3, it's 1. With the same thing. Now, let's try. If it goes wrong, then I made a mistake in the prefix sum. Okay, I don't need to see that again. I got it. That is the mistake with some indexing here. Zero two zero one. 0 0 1. It will be 1 again. Okay, now we'll get a right answer. Okay, well, we are good to go. Oof. This question also took time for me, around 45 minutes. That I got the idea after seeing the editorial. The main thing was this indexing here, where I got confused. Wrong answer on test 2. I know I messed up with the indexing for sure. I need to increase the indexing of W for this. Failed. Hmm. Sorry. I got it. I have to check for the previous one, not for the current one. That means Wi is equal to Wi minus 1. 1 will be 0 plus that is previous one. And I have to just store the cumulative sums of W's. So here it will be 0, here it will be 0, and here it will be previous 0 plus this thing. Here also it will be 0, here it will be 1. And that is why he used this thing. He'll just level up the index by 1. I equals to k, I less than equal to n, so that he could just play with the, I mean, higher indexing. For clarity of myself, I'll just print 0 1 0 0. Let me just check the original answer is correct or not. It failed here. Making mistake on the prefix. Failed. There is the mistake in this code, and that's not. I have written what he did exactly. But I think I didn't do typecasting here. No. Anyhow, this will be a How did it pass? I literally didn't get. Anyways, these are general prefix some things. Still, I'm not clear. How did the code pass and how it started working? Zero 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 zero. It will start from one. We just leave this dummy zero here, and it's the rules of prefix sum. That's it. Zero zero one 1 and 2. We just find cumulative sum of w's, and then wi minus wk, which will give the number of bytes in that particular subsequence, or the yeah, subsequence, and then we find the minimum number of those bytes in them. That's the thing we had to do. He just painted all bytes black, and then using prefix sum he found the segment which contained minimum number of bytes. Okay, well, got accepted. I think now we are done with halfway through the sheet. Red versus blue. And see if it's possible to solve this question, or else we'll continue tomorrow. Team Red and Team Blue competed in a competitive FPS. Their match was streamed around the world. They played a series of N matches. In the end, it turned out Team Red won R times and Team Blue won B times. Team Blue was less skilled than Team Red, so B was strictly less than R. You missed the stream since you overslept, but you think that match must have been neck and neck since so many people watched it. So imagine the stint of length then where I character knows who won the ith match. If it is R if Team Red won, or B if Team Blue won. Imagine the string was set the maximum amount of time. So imagine string of length n where the ith character denotes who won the ith match. If team blue won, you imagine the string was such that the maximum number of times a team won in a row was as small as possible. For example, in series of match, team red won 3 times in a row, which is the maximum. You imagine the string such as the maximum number of times a team won in a row was as small as possible. Team won in a number of times a team won in a row was as which is the maximum. Find the string satisfying both conditions. There are multiple answers. Print any. Number of test case single line containing three integers n r b. N is between 3 and 100. Okay, these constraints are pretty interesting. B and R are not equal and they're between 1 to n, and R plus B equals to n. Satisfying their multiple answer, print any. N R B. N B and R. N R and B, sorry. Input output 743. R B R B R B R. What do we have to do here is turn the team red 1 R times and team blue 1 B times. So B was strictly less than R. Okay. You missed the stream since you overslept, but you think that match have been next. Okay, imagine can with the nth character white. If it is R if team red 1 or B if team blue 1. Strings that the maximum number of times a team won in row was as small as possible. Okay. Is it not possible to do R B R B R B R B R R B. This also might be the possible thing. 1 2, which is the maximum? The maximum number of times a team won in a row was as small as possible. For example, in series, team red won 3 times in a row, which is the maximum number of test cases in B are satisfying. If there are multiple answer, print any. Okay. If we look here, then this is also fine, I guess. We just need red to win anyhow. Okay, okay. 19 13 6. R R B R R R R B R R R R B B. What about this thing? I didn't understand this test case that properly. What I could do was I would have been divided this like this. R B, which is the maximum. Okay, he is just telling this is the maximum, but he wants to tell that maximum number of times a team won in a row was as small as possible. So what we have to do is 4 and 3, R and B, 3, 1, 2, 3, 1, 2, 3. I need to place them accordingly. That's it. That's the main question here. Mm, R is N, R B. R is 4 and B is 3. 7 by 3 is, I have to place B in 3 places. If I do 7 by 3, it is 2. 1, 2, 3, 4, 5, 6, 7. I can place on this. I can place on this. 1, 2, 3, 4, 5, 6. I can place on this. And R here, R here, R here, R here, which is 1. Yeah, that's what we had to do. And let's say I have 6, 5, and 1. And RB 6 by 1, which is 6. At index 6 only I will be able to place it. One, 2, 3, 4, 5, 6. R is equal to 5, B is equal to 1. I just need to distribute them optimally. Or else what I can do is I'll just print B, then R, then go on printing whatever remains. But this won't be the possible. This won't give me the minimum answer. N R B and 6, 5, 1. 6 by 2 is 3. I can place it as 6 by 2. Then if suppose b was 2, then I would place it at 3, 6 by 4, and 6 by 8. No, 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 no. See, there are 6 places. One, 2, 3, 5, 6. No, I have to place b somewhere or somewhere where I need to minimize the amount of r's. Here b is 1. 5 minus 1 is 4. 1, 2, 3, 4. 5 by 2, 3. If I have 4, 13 by 2. This problem is quite interesting to be honest. This like the thing is that we need to imagine how and where do we have to place that b, and r plus b is equal to n. That's one more thing. 19, 13, 6. And it's 13 and 6. 5 and 1. We have to divide 5 into two parts. 13 can be divided into, no, 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 no. If I do in 13 parts, then I'll do R B R B R B R B R B R B. It will be like 6 times, and then 13 goes on for 7 times. Some other thing which I can get from here, from these test cases. If n is odd and if n is even. N is equal to a plus b. Let's say if n is odd. If n is even, then a and b both are even. Because even plus even, no, 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 no. Either a and b both are even, or either a and b both are odd. If n is odd, then A is even, B is odd, or B is odd and A is even. If n is odd, then let's say n is 5. 1, 2, 3, 4, 5. And if B is odd, then B is odd, then where could I place it? B is odd, then and could I place it here? And I'll probably go for the center index. Let's say B is 1. Then I'll go on this index 0, 1, 2, 3, 4. I'll go by n by 2 index. N by 2, 0, n by 2, n minus 1. These are what indices I'll prefer. I have to look for some patterns here. Let's say if it's 19 and 6, 0, n by 2, n by 4, n by. or maybe with 3 b's I have to divide array into 4 parts. That's what the thing is. So in the first test case, let's see 4 by 1. So I'll be appointing each one are here. We're back.